Hello students, today we are going to discuss JEE Mains 2026 first phase, that is morning shift first phase. We are going to discuss. The first question, consider the following reaction. Now the compound A reacts with H2PT, that is hydrogenation. You are getting that this compound, right? And the same compound A, when it is reacts with a hot alkaline KMnO4, that is Bayes reagent, you know very well, and H plus H2O, acid hydrolysis, you are getting phthalic acid. Now what is the compound A? That is what we have to check it from this option. Actually, it's very interesting question and important question also. Come on, let us discuss. Okay, the first point, what it mentions, H2PT. This is nothing, hydrogenation. Hydrogenation. Hydrogenation, what it happens, it reduces alkenes and aromatic rings. Aromatic rings. See, so that means this H2PT hydrogenation reducing reagent only reduces alkenes and aromatic rings. So that means which is alkene and aromatic ring? Alkene it has to be, that means double bond it has to be present. But here there is no aromatic ring. Here also there is no aromatic ring. Okay, cyclohexane, like such kind of thing only. Cycloalkene only it is there. But here aromatic ring is there, but here there is no double bond. So we can consider this point. So the bond started breaking over there. So when the bond started breaking, so alkene converted to alkane. So that means the double bond started breaking and forms fully saturated. So alkene converted to fully saturated alkane, bicyclic compound. Fully saturated bicyclic compound. Bicyclic compound. All right, got it. So this is for that first point, right? Now this is the first one. Now the second one, alkaline KMnO4. So we are planning to get this. So that means this is only the correct option. The rest of that there is not at all a matching. So option A for this. Now option, that means the same compound, this compound, when it is reacting with alkaline KMnO4. What is it, alkaline KMnO4? Hot alkaline KMnO4. What it is called, you know, it's Bayes reagent. Bayes reagent. So what actually we are using for Bayes reagent, no? It oxidizes. Actually, it is KMnO4, it is an oxidizing reagent. So it is a strong oxidizing agent. Actually, it is a strong oxidizing agent. So what it uses, it oxidizes alkene. Okay, it oxidizes alkene, alkyne and aldehydes into benzoic acid. That means carboxylic acid. That's all. Okay, so it oxidizes alkene. That means here what it is, double bond, triple bond, and aldehydes, CHO, there also you will get double bond, okay, with oxygen. So that will be converted to what it is, carboxylic acid. Okay, so that means adjacent carbon, double bond it is there or triple bond is there, both the same carboxylic acid will be attached. So that means here I just draw the structural formula for you to understand. So that means here what it is, compound A, option A, I just bring that structural formula for you to understand. So this is a double bond. Now when it is, this is a compound A, when it is reacting with hot K, what it is, H2PT hydrogenation, you are getting this compound, that is benzene along with cyclohexane, right? So this is that first one. And the second one here, the same compound when it is reacting with hot KMnO4, that is hot alkaline KMnO4. So along with H2, that means H plus H2O, like acid hydrolysis. So you will get what it is, carboxylic acid, COOH, phthalic acid. So you will get it. So first and foremost, so what are the things are applicable? Aldehydes, alkenes, alkynes, whichever compound is representing with that aromatic ring, automatically it converts carboxylic acid. So that is what here double bond is there now. So this double bond started breaking and it changes to carboxylic acid. And the same way here also, double bond breaks and you are getting alkane. Right? I hope you got the clear idea about this question. This is very interesting question only. The first question, what you are seeing, and it's very easy also. I hope you have done this answer. Come on, let us go to the next question now. Which is the correct option? Option A. That means option 1 is the correct option. Okay, come on, let us go to the next question. The next question. In sulfur estimation, 0.7 gram of an organic compound gives 1 gram of barium sulfate by Carrier's method. What is the percentage of sulfur in compound? It is actually very interesting and important question only. Already we have gone through in the NCERT textbook, second question only. This is the same second question only it has asked here also. Now, come on, let us discuss. Actually, here 2 points you have to determine. Okay, the first point, what it is, actually here, the first point, what you have to observe, it is mass of sulfur. So here, mass of sulfur you have to identify. Mass of sulfur you have to identify. The second one, percentage of sulfur you have to identify. So first thing, mass of sulfur, how to identify? Come on, let us go for it. So mass of sulfur equal to mass, here actually it is mass of barium sulfate. Barium sulfate, okay, barium sulfate. See, this is barium sulfate they have given now. So barium sulfate into molar mass of sulfur divided by molecular mass of barium sulfate. Molecular mass of barium sulfate. See, you can give atomic mass also. I just mentioned molar mass. Molar mass means 1 mole of an atom of the sulfur also we can say. Or else atomic mass of sulfur also you can give. Molar mass, it is nothing, 1 mole of an atom of sulfur. Okay, now first thing we have observed this. Okay, now here mass of barium sulfate they have given no organic compound and 1 gram of barium sulfate. So that is the way we have to identify. Okay, now the next point, what it is, percentage of sulfur. So percentage of sulfur, how do you identify percentage of sulfur? Here what it is, here mass of sulfur, here this one only mass of sulfur we found here, right? Mass of sulfur divided by organic compound. Organic compound, what it is organic compound? Here they have given us 7. Okay, that one. So organic compound, mass of organic compound. Right, that's all. Okay, I hope you got that idea. How do we go and identify? See, if you know the concept, it is actually easy. That is what, if you are, you want to become as a topper person means, toppers are not born. They are trained. If you go on practice, if you go on learn the concept, you'll be thorough. Whatever question they are giving, if you know the track, your train will go on the track. I hope you got the clarity about these questions. Come on, let us go and identify the answer with these 2 idea. Okay, now first one, mass of sulfur, what I mentioned. See, here mass of sulfur. First point I just mentioned, mass of sulfur equal to what it is. Here, mass of barium sulfate 1 gram into molar mass of sulfur, how much? It is actually 32 divided by molar mass of barium sulfate, how much? Molar mass of barium sulfate 233 gram per mole. Right, here this also gram per mole only. Right, okay, so now here in this into 10, because percentage, no, here I just forgot. Okay, now what is the answer you'll be getting when you calculate 32 divided by 233? So naturally what you have to, what it is, increase the digit so that you will put it 0 point. Okay, so that means here 0 point. Okay, here 330 you'll be getting, no. So when you calculate 233, here 332. So when you are calculating 2, it will be 4. Okay, so that means directly 1. So same, like a simple way you can go. It is not so hard to divide, or simple way, like then only you will get that idea. Okay, now the second, when you are calculating this, you will get this one, 1373 you will be getting. Right, okay, now this is actually what it is, mass of sulfur, no, so gram, right? That is the unit you can provide. The second step, so this is actually what it is, mass of sulfur. So mass of sulfur we found. Now the second step, what it is, what is the second step? It brings the second step, what it is, percentage of sulfur. Okay, percentage of sulfur. So percentage of sulfur, what it is, mass of sulfur 0.1373 gram divided by organic compound, how much? Mass of organic compound 0.7, right? 0.7. So 0.7 gram. Right, so 0.7 and this one 0.1373. Okay, that into 100. Sorry, I just into 100. So what is the answer you'll be getting? Around here 7, here 13. So 7 ones are 7, 7 twos are 14. So 13 only, no. So 1, and then again. So when you calculate, no, this is 19.61% you will be getting. So 19.61%. Actually, the same question in that NCERT second question, it is they have given in that half of that only the. Here it is 0.5 something, 0.5 something grams. Right, in that barium 1 gram they have given, but actually barium sulfate it is 0.5 something grams, and here they have given another some, but the same question it is repeated in a different way. 15 grams, yes, exactly, 0.15 grams. Here they have given 0.7. That's what I just mentioned. Half of that they mentioned, they have given, right? Actually, the same question, same concept, they have given, changed the value. Okay, now which is the correct option? 19.61 only it's coming. So 19.61, and what is this actually? 19.61, it is a percentage, right? So this is a percentage. Okay, so option 1, it is a correct option. I hope you got the clarity. See, as you observe the question, actually it is, you have known already, you have done, and during class time teacher might have taught this topics and this lessons and this ideas and all they have given. Okay, once you have learned and you practice it, it will be very easy for you. It is not so tough or hard, it is very easy. But calculation part and all, you have to be thorough. Okay, come on, let us go to the next question. The next question here, observe the following reaction sequence. Compound P, when it is reacting with ammonia, while heating, you are getting compound Q. They did not mention which compound, PQ. And that compound Q, when it is reacting with Br2KOH, that is Hoffman's degradation. Br2KOH, it is Hoffman's degradation. You are getting R. Which of the following correct structure for PQR? Only Q, I mean only key, what they have given, that is bromine with KOH. That is, okay. So that is degradation. That means number of carbon will be decreasing. That is that point we just remember. Okay, now here, ammonia, when it is reacting with option 1, carboxylic acid, so you will get amide. Okay, ammonia when it is reacting with it. Now H plus, here this is base, mild base, this is acid, so acid base reaction, so you will get amide, salt and water, like so. Here OH, here H, so automatically it releases water, amide, CONH2 will be getting. Right now here amide, when it is reacting with Br2KOH, so KBr, like what to say, here what it is, one hydrogen will be going out, and here actually carbon dioxide, one carbon dioxide will be going out actually. KOH, KBr will be coming, and here NH2. So option 1 actually it is correct. Come on, let us check other 3 also. Here carboxylic acid. Yeah, first one option carboxylic acid. I just draw the structural formula, then we can go for. Just I've given the idea for you to understand. Okay, so here first one what it is. Here first one carboxylic acid. No, this is benzoic acid. So this is COOH combined with the NH3 while heating. While heating, what you will get, one H hydrogen and here OH. So both releases water, right? So naturally salt and water, no, in that way CONH2. That's all. Right? Simple, very simple. They have given CONH2. So this is amide NH2. So this is what it is, P. Okay, that is compound P. Okay, now next one. Yeah, compound Q. Okay, so this one amide, when it is reacting with CONH2 combined with what it is, Br2KOH. So Br2KOH, it is Hoffman's degradation. Okay, Hoffman's degradation. Degradation, usually it releases 1 carbon. Okay, generally, if for example 6 carbon is there, means 5 carbons only is the product. In that way, that is a simple key. So here what happened, Br2 KBr, it releases KBr, and what it is here also, carbon dioxide, it releases 1 carbon, it is reduces, right? Already I mentioned. So you will get NH2. So aniline is that compound. Okay, so option A, actually it is, that means option 1 it is correct. But here carboxylic acid, yes, this is fine. But here COO minus NH4, this will not be the correct option. Third one, degradation, no, so that means here amine, that means aniline compound will be coming. So option R and Q will not be correct. And the same way, starting only ammonium, it will not be possible. Why? Because it releases water. This is acid, and ammonia, it is base, acid and base, salt and water, like CONH2 plus H2O. You'll be getting right. Okay, now so this also it's wrong, and carboxylic acid, it is fine. Aniline, first only it will not go for degradation. First one, what it is? Carboxylic acid. The second one, it is degradation. And the third one, benzene. How come it is possible? Okay, so here this is P and this is Q. This is P and this is Q. And this is R. Okay, I just mentioned here Q. This is Q and this is R. I hope you got the clarity. So PQR is actually what it is. Option 1 is the correct, carboxylic acid and amide and aniline, primary amine, right? I hope you got the clarity. Come on, let us go to the next question. Next question. In the following reaction, MnO42 minus, in the presence of acidic medium, manganate ion undergoes disproportionation in acidic medium to form. So what are the products? They mentioned in a key answer way here. Actually, disproportionation reaction they mentioned in the acidic medium. Disproportionation means what it is? Actually, simultaneously, It loses electron and it gains electron. So loses electrons means what it is? Oxidation. Loses electrons means oxidation, and gain of electron means reduction. A reduction. So oxidation means loss of electron, and gain or reduction means gain of electron. Right, in this only they mentioned key answer, right? That they mentioned acidic medium also. Okay, that means what are the products you'll be getting? Okay, now here MnO4 2 minus, in the presence of H plus ion we are getting here MnO2 plus MnO4 minus, MnO4 minus plus H2O you'll be getting. Right, now this is the product. Okay, now simultaneously loss of electron, gain of electron. No, so how do we identify? Okay, now oxidation number, this is X and this is oxygen O4, so 2 minus, so already it is minus 8. X plus minus 8 equal to minus 2, so that means this is plus 6 oxidation number. So first reactant, it is a plus 6 oxidation, whereas here plus 2 oxidation. Right, now here what it is? Here the same way, here plus 7 oxidation. Right, the same component here, manganate ion undergoes disproportionation in acidic medium to form. So here manganate ion undergoes disproportionation. So simultaneously it is oxidized and reduced. So two different products you are getting. So that is higher and lower oxidation state. One we are getting very lower oxidation state, the other one we are getting higher oxidation state. So in that way we can consider it as a disproportionation. Okay, now balancing that equation. Now here actually 3. So that means here you will get 2 and 2 molecules of water. So 2 molecules of water means 4 H plus ion. I hope you got the clarity. How do we go for and how do we perform this reaction? And of course, the main point, disproportionation. Also, you got it. Okay. The same component which oxidizes and reduces simultaneously. One you will get higher oxidation state, the other one you will get lower oxidation state. In that way, we can consider, right? I hope you got the clarity about this question. Come on, let's go to the next question. The next question, 80 ml of organic compound mixed with 264 ml of oxygen or ignited. It gives 224 ml of gaseous mixture at NTP. After passing through KOH, 64 ml of gas remains. The organic compound is. Right, now, actually, the formula what we are going to use it is X and Y. Okay, carbon and hydrocarbon formula, no, that only we are going to use this. Okay, now here, X, CXHY, right, CXHY plus X plus Y by 4O2. It gives X CO2 plus Y by 2 H2O. So this is the formula we are using to find the answer. You know this formula very well. Generally, this many questions we have practiced it, this kind of. Okay, temperature what they have given at present. Now that means before reaction takes place. Temperature it is 0. And volume how much they have given? 80 ml. That is organic compound 80 ml they mentioned, right? Okay, so 80 ml they mentioned. And compound mixed with 264 oxygen. So here what it is? 264 ml of oxygen. Right. Okay, now it gives 224 ml of gaseous mixture at NTP. So here gaseous mixture they have given. So what is it actually? 224 ml. Actually what it is? Gaseous mixture. Gaseous mixture. Right. Now here in this point, after passing through KOH, this point, 64 ml of gas remains. The organic compound 64 ml actually remains. The remaining gas, how much it is? 64 ml. So what is the organic compound? That is the question. Organic compound. Right, now come on, let us check what is it. Actually very clearly it has mentioned. Okay, now here the gaseous mixture is what it is? 224. It gives, after reaction, it gives 224. After passing through KOH, 64 ml, it remains in that reactant only. So how much it has left over? Actually, left over at a 64 ml. Right, now used how much? So used how much means this is actually 264 it started using. In that 64 ml raised, I mean left. Okay, so that means used equal to 264 ml minus 64 ml left. Right, so how much it is used actually? 200 ml it is used. So used it is actually 200 ml. Please remember this, 200 ml it is used. And formed how much? Volume of carbon dioxide. It is formed. formed how much? It is actually 224. It is a mixture of gases. Minus 64, it is left. Right. So that means how much it is? 160 ml it is formed. So that means 160 ml only it is formed. That is carbon dioxide. Now oxygen we have to identify. Okay. Now here 1 ml what it is? Carbon X hydrogen Y equal to X ml of carbon dioxide. So in 1 ml of hydrocarbon, it provides X ml of carbon dioxide. Therefore, 80 ml of 80 ml of hydrocarbon CXHY equal to 160 ml. That is what here we got it now, carbon dioxide 160 ml. Right. Now, therefore, here 180 ml of hydrocarbon can provide 160 ml of carbon dioxide. So here what we can do, 160 divided by 80. So that means here X we can identify. What is it X? See here X equal to what it is. This is X now. 1 ml of hydrocarbon provide X ml of carbon dioxide. Therefore, 80 ml of hydrocarbon can provide 160 ml of carbon dioxide. So, X ml of carbon dioxide, X is equal to, so here X equal to 2. You got it. So, 2 ml. Right now, X, that is X, we got it. Okay, now carbon, X, hydrogen, Y. So, carbon number we provided, so that is 2. X equal to 2. Now, we have to find out Y. Okay, in that CXHY, no, in that CXHY, X, it is 2. Now, Y we have to identify. Okay, come on, let us check here. So here volume of CXHY divided by 1 equal to volume of oxygen used. Right. Okay, so here what it is? 80 equal to, this is 80, right? 80 equal to 200. 200 is what it is? Used of what it is? Carbon dioxide divided by 2 plus y by 4. So 2 plus y by 4. X plus y by 4. For now here what it is? The formula of equation. Formula of equation here I have given that clarity. So here it is, this is, let me check it once again. Yeah, here X plus Y by 4. Oxygen, no. That is what I just mentioned here. X it is what it is? 2. We found now X equal to 2. So X plus Y by 4. Okay. So that means here 160 plus 20Y equal to 200. 160 plus 20y equal to 200. So that means 20y equal to what it is? 200 minus 160. So that means y equal to, here what it is? 20y equal to 40. So therefore y equal to 40 by 20. It is how much? 2. So x also 2, y also 2. That means here what is the answer? C2H2. What is it? Organic compound? Acetylene. Right. Acetylene C2H2 only is the compound, organic compound name. I hope you got the clarity. Now what is the answer over here? C2H2 is the answer. C2H2 is the answer. All right. Okay. Come on. Let's go to the next question. Question. Which of the following is correct order with respect to the property indicated? Fluorine is greater than fluorine ionization energy. K2O is greater than Na2O, it's greater than Al2O3, basic in nature. Potassium, sodium, aluminium, magnesium, metallic character, none of these. Okay, now according to that periodic table, it will be easy for us to identify the answer. Here, fluorine, chlorine. Here, halogen, no, fluorine, chlorine. Fluorine ionization is higher than chlorine because atomic size is small. So easily ionizable, atomic size is smaller, easily ionizable. So F it is greater than Cl, but here they have given chlorine is greater than fluorine. So that option, it is not at all correct. Then next one, basic in nature. Potassium, sodium, aluminium oxide, that means K2O, Na2O and Al2O3. Al2O3, it is amphoteric in nature, neither acid nor basic. So it is amphoteric in nature, whereas potassium and sodium, it is completely alkali metals. So here potassium, as it is going from top to bottom, here actually lithium, sodium, potassium, rubidium, cesium, francium. So as it is going down, so basic nature, it is actually increasing. So least basic, it is actually Al2O3. So generally what we will say here, Al2O3, it is the least basic, then magnesium oxide and sodium oxide and potassium oxide. So sodium oxide, it is comparatively less basic than potassium oxide. So what they have given this point, It's correct only. So potassium, it is more basic. Next to that, sodium oxide, then Al2O3, it is the least basic in nature. It is 100% correct. Come on, let us check another two. Okay, now here K, that is potassium, it's greater than sodium, it's greater than aluminum, it's greater than magnesium. It is metallic in character. So metals, generally in the periodic table, metals, metallic character decreases from left to right. From left to right, metallic character actually what it is, decreases from left to right, metallic character decreases, whereas top to bottom, from top to bottom, right, from top to bottom, metallic character actually increases. Metallic character will be increasing. So from left to right, metallic character decreases. From top to bottom, metallic character increases. So that means here what they have given, sodium, it is greater than, oh, sorry, potassium, it's greater than sodium, that is aluminum, then magnesium. Here actually the correct option might be here potassium, sodium and magnesium. Last only aluminum will be coming. But here just displacement it has taken place. So this will not be the correct option. So the correct option, it is option 2, basic in nature. K2O, it's greater than N2O, it's greater than aluminum Al2O3. Hope you got the clarity. Come on, let's go to the next question. The next question, given below are two statements. Statement 1, arginine and tryptophan are essential amino acids. It's exactly correct. They both are amino acids. Statement 2, glycine does not have any chiral carbon. Of course, actually, what is the molecular formula of glycine? It is carbon, which is connected with NH2, here COOH, and here hydrogen, and here hydrogen. So chiral carbon has 4 different groups or atoms. That is called chiral carbon. So what do you mean by chiral carbon? That 4 different groups, for example, A, B, E, D. So 4 different groups or atoms attached to that carbon. That is called chiral carbon. Whereas here 2 hydrogen, same atom, it is available. So that means it does not have chiral carbon. Of course, statement 2, 100% it is correct. Statement 1 also it is correct. Statement 2 also it is correct. So the option 1, both statement 1 and 2 are correct. Of course, it is 100% correct. So option 1 is the correct option. Hope you got the clarity about that first one and second one. Come on, let us go to the next question. The next question, consider the following reaction. Calcium Ca plus 2HCl, it gives CaCl2 plus H2. We have 14 gram of calcium reacts with the excess of HCl. Choose the incorrect option. So among these, which is that not correct one? Okay. Now mass of CaCl2 produced is 38.85 gram. Come on, let us check with the calculation. Mole of H2 hydrogen produced is 0.35 mole. Volume of hydrogen produced is at STP, they have mentioned STP, 7.84 liter. Mass of calcium, CaCl2, calcium chloride, produced is 3.885 gram, right? So here mass of calcium chloride produced, here mass of, so both the answer. Come on, let us check. So before going for this, come on, let us go and identify the number of moles. So it will be easy for us to identify. So with this reaction, here 14 gram of calcium they mentioned. So number of moles, let us go. Number of moles equal to given mass by atomic mass. Right now 14 gram divided by 40 gram per mole. So how much it is? Actually here 0.35 mole. So here mole, in this equation, 1 mole of calcium produced 1 mole of hydrogen. A mole of hydrogen produced is 0.35 mole. Exactly, it is correct. Okay, a mole of hydrogen produced is calcium, that is 0.35 mole. Okay, now volume, let us check here. Hydrogen, volume of hydrogen produced is at STP 7.84 liter they mentioned. Okay, now here 1 mole of calcium, 1 mole of calcium produced 1 mole of hydrogen. Therefore 0.35 mole of calcium produced how much of hydrogen? So 0.35 into 22.4 liter, right? At STP. Okay, at STP. This is STP, right? At STP means 22.4 liter only. So what is the answer you will be getting? You'll be getting 7.84 liter. Right, you got it. So volume of H2 produced, it is 7.84 liter. This also it is a correct answer only. Right, now next one, mass of calcium chloride. So the next one, it is mass of calcium chloride. Third point, mass of calcium chloride. So mass of calcium chloride, it is actually what it is, generally mass of the compound, number of moles, that is moles into molar mass. So mass of this compound you'll be getting. So number of moles, how much? Here 0.35 into calcium chloride. What is the molecular mass? Molar mass, how much it is? 111. Okay, so this is 40 and this is 70, right? 35.5, right? So 35.5 into 2, so 70. 70 plus 40, 110. This is one extra. Okay, so this is 111. Okay, so how much you are getting here? You'll be getting actually 38.85 grams. So mass of calcium chloride, it is 38.85 grams. Yes. Okay, now let us check the answer. So mass of calcium chloride, here only we can identify. So that is what first starting only I've gone for, number of moles. So it will be easy. That is the starting point. Okay, so number of moles. Yeah, that is actually mass of calcium chloride. It is 38.85. Yes, it is correct. Mole of H2 produced, it is number of moles of calcium. It is 0.35 mole. Yes, volume of H2 produced is at STP is 7.84 liter. Yes, this also correct. Mass of calcium chloride produced 3.885. No, totally it is wrong. So which is the incorrect option they have given? So that incorrect option, it is fourth one. So that means that incorrect correct option, it is actually fourth option only is the correct option. I hope you got the clarity. How do we go for? Suppose if they are giving such kind of questions. The next question, C6H12O3 gives positive iodoform test on hydrolysis with dilute acid. The hydrolysis product formed gives tolerance and iodoform test both. Find the structure of C6H12O3. Right now here, iodoform test. See, this is basically, this is what it is. Memory based questions only. So in our starting classes, there are so many questions we have gone through. So in the practice questions, everything I mentioned very clearly. Methyl keto group, right? Methyl keto group present in the terminal or starting of that. Okay, methyl keto group presence or secondary alcohol group present means these two group present means that will be answerable for iodoform test. Iodoform test. Right, I just mentioned very clearly, this is completely based on memory based questions and it's very interesting question also. So before going to check the option, I'm giving that idea, how do we analyze the answer, right? Now here, the next point, aldehyde. So aldehyde, how do we identify? Aldehyde means aldehyde. Here they mentioned, so aldehyde will be answerable for Tollens reagent, Tollens test. Right, so through this idea, we can identify the answer very clearly. Now, secondary alcoholic group must be present and the methyl keto group in the terminal, right? Of course, methyl keto group will be there in the terminal only. Suppose if it is keto group is there in that middle or some other place like ethyl, such kind of propyl, like you will get it. So methyl, it is a terminal point only. You'll be getting only one carbon, that is CH3, C double bond O, like that only methyl keto group. Yes, of course. Come on, let us check the answer here. So these two points. Let us check the right correct exact idea. CH3, C double bond O, CH2, CH2, CH, here OH, here OCH3. Right, now in that dilute HCl, right, acid, dilute acid if it reacts. So what is the product you'll be getting? This is H plus ion. No, so H plus ion which is going to attract over here, lone pair of electrons out there. No, so naturally you will be releasing what it is, CH3OH, right? CH3OH if it reduces, so automatically this one here, what is the answer you'll be getting? Here, this is that second product. This is the second product. Then the second one, what you will get it, CH3, C double bond O, CH2, CH2, CHO. You will be getting CHO, right? So that means here this hydrogen, which is, it goes outwards, that Cl minus is there, no, dilute HCl. So this H plus ion, which is attracted towards that negative charge of Cl minus ion. So you will be getting aldehyde. So here you will get the keto group, here you will get aldehyde group. So keto group, aldehyde group, of course, this is a methyl keto group and this is aldehyde. So methyl group will be answerable for what it is, iodoform test, that is dihalide. Okay, so this is what I mentioned here, iodoform test, iodoform test. Right, now this will be answerable for Tollens test, that is silver mirror, right? So Tollens test. Right, so it will be easy for you to identify the answer. Right, I hope you got the clarity. So this is actually what it is, salt plus trihalide you'll be getting here, CHI3 you'll be getting added to that salt formation, right? I2 plus NaOH. Right, so you'll when it is reacting with this compound, you'll be getting iodoform test, and this CHO aldehyde group, if it is present, means you'll be getting what it is, silver mirror test when it is reacting with Tollens reagent. I hope you got the clarity. Now, how do we identify this is a secondary alcohol and this is a methyl keto group? So that is the way I just identified, right? Okay, that is what this is completely based on memory based question, and it is a logical way thinking also. It will be easy. Already you have done number of questions like this, and I've explained in my previous videos also. So please check it if you want, right? Come on, which is the correct option? Okay, now which is the correct option? CH3, C double bond O, CH2, CH2, CHOH, OCH3, that is ethyl. Okay, now option, which is the correct option? Option 1 only is the correct option. I hope you got the clarity. Come on, let us go to the next question. Next question. Given below are two statements. Statement 1, all the pairs of molecules PbO, PbO2, SnO, SnO2, and GeO, GeO2 contain amphoteric oxides, whereas statement 2, AlCl3, BH3, BeH2, and NO2 all have incomplete octet. According to the statement 2, it is completely correct actually. AlCl3, it is incomplete. According to Lewis dot structure, you have known very well. So this is actually incomplete octet, 100%. BH3 also incomplete octet only. BeH2, everything. Right now here, I'll just give one example. Al, here actually, what it is, 1, 2, 3, right? Lone pair of electrons, right? So here Cl 1, 2, 3, 4, 5, 6, 7, and here 1, 8. So automatically here also the same 1, 2, 3, 4, 5, 6, 7, and here 1, 8. So like this way only. So here actually what it is? It is incomplete octet. It is not a complete octet. Even BH3 also the same incomplete octet. BeH2 also incomplete octet. NO2 also incomplete octet. So 100% it is correct only. Whereas here PbO, PbO2, and SnO, SnO2, GeO, GeO2. Generally here actually amphoteric in nature. So germanium, it is amphoteric in nature, whereas Sn and Pb or P block elements. So generally here basic in nature. This is actually basic in nature, we can say, but it is amphoteric. It will be answerable for acidic as well as basic, right? And even SnO2. So just I brought that idea for you, this catalog for you. So here amphoteric in nature, acidic in nature, and basic in nature. That means oxides, basic oxides, amphoteric oxides, and acidic oxides, right? So here GeO2, it is actually what it is, acidic. Generally, it will be answerable for acidic in nature, whereas SnO2 and PbO2, it is amphoteric in nature. So these SnO, SnO2, PbO, PbO2, these both are amphoteric in nature, right? Whereas GeO and GeO2, this is actually acidic. This is completely acidic. Sometimes it will be answerable for basic also. Why? Because it is what it is, metalloids, no, so it has basic character as well as acidic in nature. So germanium, it is actually what it is, metalloids. This part, it is completely metalloids, no, so in that way, so it is completely amphoteric in nature. So distinctly it is actually acidic in nature also, right? Okay, so which is the correct option? I mean, on PbO, PbO2, and SnO, SnO2, we can agree it is an amphoteric in nature, whereas GeO, GeO2 completely acidic in nature generally. Okay, so fourth option, statement 1, it is incorrect, and statement 2, it is completely correct. Hope you got the clarity. Okay, come on, let us go to the next question in our next video, and thank you for watching.